Hello everyone, today we are going to discuss a question of grade 21 and topic is topology. We have to only check that given topological spaces are connected or not. For this we have to know first definition of connected. Our topological space is said to be connected if it has no separation, and for separation we can say if x tau is given topological space, A and B are two open set in this topological space such that A union B is X and A intersection B is phi. Then we say that this topological space has separation, means open set A and B form separation of this topological space. And if it has separation, then space is disconnected, means not connected. So for T1, our first topological space is RT1, where T1 is upper limit topology, means that every open set in this topology is union of elements of this type. So let us consider A equals to minus infinity 1 closed and B open 1 infinity. We have to see that these two elements are open in this topological space or not. So clearly we can write union n equals to 1 to infinity and minus n open 1 closed, and B as union n equals to 2 to infinity 1 n. Now see that this element and these elements are basis elements in this T1 topological space. So this is, and we know that arbitrary union of open element is open in topological space and basis elements are always open. So this is arbitrary union, this is also arbitrary union. So A and B are open set in this topological space. Now clearly A union B is our R and A intersection B is phi. So we got a separation of this topological space x1. It means that x1 is not connected, means disconnected. Now x2, first notice that in x2 element u belongs to x2 is open if u complement is finite, means r minus u is finite, it is same as u complement. Now let us suppose that this x2 space is disconnected. If it is disconnected, then it will has a separation. Okay, let us suppose that it has a separation, so we can write a comma b belongs to x2 such that a union b is equals to r and a intersection b is equals to phi. Now see this, take complement both side. So what we got, a complement union b complement is equals to r, complement of phi is r. Now we assume that a and b are element of x2. This implies that a and b are open elements of x2. This implies that a complement is finite. Similarly, b is also element of x2. This implies b complement is finite. So what we got, this is finite, this is finite. So union of finite thing is finite, but what is here, r, this is infinite. So we got a contradiction. What we suppose that this space has a separation, we got a contradiction. This means that this space has no separation. It means that this space x2 is connected. So third option is correct, x1 is not connected and x2 is connected. Thank you so much.